Something didn't come home. High in the Rockies, above the tree line where the air thins and the rocks never warm up, a piece of American aviation history is lying broken in the scree. What you're looking at is not scrap metal. This is the main rotor system of a utility helicopter, a machine built to save lives, and right now it needs saving itself. Welcome back to Aqua Revive Restoration, the channel where we take what's broken, battered, and written off, and we bring it back. I'm out here today in the northern Alpine range with a recovery and documentation team, and what we've found is extraordinary. A complete main rotor hub assembly, 1.1 meters across at the hub, 2.3 meters of mass section still attached, lying half buried in loose mountain rock with its swashplate intact, its pitch links still connected, and carbon fiber blade fragments scattered in a 40-foot arc around it. The colors tell the story before you read a single technical report. That dull silver-gray finish, aluminum and titanium baked in decades of thermal cycling, catches the flat Alpine light like a ghost. You can still see patches of the original aircraft gray paint, a soft blue-gray the color of an overcast sky at altitude. And then there's the orange. Rescue orange straps tagged and weathered, fluttering at the ends like tired flags. Someone's already been here. Someone already tried to mark what mattered. Our job today is to continue that work. Systematically, respectfully, and with the kind of detail that only this channel brings you. Before we touch anything, we walk the perimeter. Standard forensic protocol. The hub is the anchor. Everything else radiates out from it. 3 major blade fragments are visible within 15 feet. One is wedged upright between 2 boulders. Another is lying flat with its leading edge pointing downslope as if still trying to fly. And the third, the most dramatic, is shattered at the root, its black carbon fiber layers peeled open like the pages of a book left out in the rain. This is a composite structure, carbon fiber over a Nomex honeycomb core. When it fails, it doesn't crumple, it detonates. And the evidence of that force is written all over this hillside. First light is the best light for reading damage. A flashlight beam dragged along a fracture surface tells you more than a laboratory scan sometimes. The shadows fill every valley, every delamination plane. Look at that blade root. The black layers are frayed like burned fabric. Hydraulic fluid has trailed down the casting and frozen in place overnight, dark as old motor oil. And there, on the steel fasteners near the mast flange, the only rust we're going to find on this whole assembly. Titanium and aluminum don't rust. Steel does. It's a reminder that not everything here was built to last forever. Some of it was just built to hold. You cannot move a piece like this without respecting its weight. The hub casting alone runs over 200 pounds. With the mast section, the swashplate assembly, all the attached hardware, you're looking at moving nearly 600 pounds of precision machinery off a slope that no truck will ever reach. The team begins threading rescue orange lifting slings through the hub's rib structure, finding the geometry of balance before a single pound of tension is applied. Carabiners click into place, shackles are pin-locked, safety wire gets checked, double-checked, and checked again. Up here, everything is a test. While the hub team rigs, I'm taking a few minutes to document the mast splines. This is the interface where the rotor translates rotation from the gearbox into lift. The mechanical handshake between engine and sky. The splines are scraped bright at their high points, the dull gray oxidation pooling in the valleys between teeth key water in a canyon. This kind of wear pattern has a story in it. The droop stops catch my eye. These small mechanical gates, polymer and aluminum, are what prevent the blades from hanging too low when the rotor is stationary. Under gravity alone, a 20-foot blade will droop enough to strike the fuselage if nothing stops it. You can see the paint chipping here, light aircraft gray flaking away to reveal bare aluminum beneath. And between the mechanical surfaces, a thin crust of ice crystals has formed overnight. The mountain is preserving evidence we haven't found yet. The blade fragment wedged between rocks comes out first. It's a careful process. Wiggle, not pull. Carbon fiber fracture edges are razor sharp. The orange sling cinches around the fragment's midsection, and for a moment it hangs in the air, turning slowly, and you see both faces at once. The clean aerodynamic profile on one side and the catastrophic delamination on the other. Black layers. Thousands of individual carbon fiber strands, each thinner than a human hair, fanned out into the cold air. This piece alone is worth hours of laboratory analysis. The light dies fast up here in late autumn. By the time the second blade fragment is tagged and the bearing housings are photographed, the team is working by headlamp. And I have to tell you, there is something about seeing this machine under artificial light, in the dark, on a mountain, that strips away every romantic notion about aviation and replaces it with pure awe for the engineers who designed it. The hub glints silver in 6 intersecting beams. The orange tags glow like embers. The documentation continues without pause. The extraction helicopter arrives just after dawn. There's something almost poetic about using a helicopter to recover helicopter parts. Lift rescuing lift. The taglines go taut. The orange straps pull to full tension. And then, with a sound like a canvas sail catching wind, the hub and Ast section leave the mountain for the first time since they came down. A puff of snow and dust rises, then settles. The scree remembers the shape of what was there.
The clean
in an hour, it will
Swashplate
fill
is
back in,
displayed
and
in
you
a
won't be able to tell
museum-like
anything
order.
ever rested
The
here at
droop
all.
stop wear pad shows
From the landing
a
zone,
polished
it's 2 hours on
contact
mountain
surface.
roads to our workshop
All
facility.
pieces
The hub and
confirmed.
mast
The
are
hub
loaded
photo
onto a utility
matches.
flatbed, strapped down
Yes,
with orange
the
webbing at
last
4
flag is
points.
clear.
The yellow evidence
Good.
tape markers still
Site's
intact
clear.
on every documented surface.
Rotor
In the truck
system
bay,
lock
surrounded
confirmed.
by foam padding and
Hub
ratchet straps,
mechanism
the
secure.
rotor system looks almost
All
comfortable,
components tight.
almost at rest.
Checklist complete.
It has no idea what's coming. Not more violence, but something harder and more demanding. Attention to detail. Bright LED overhead lighting, epoxy-coated concrete floors, the smell of solvent and machine oil. This is where things get precise. The parts come off the truck on a specialized cradle and go straight onto numbered pallets. Every tag is counted. Every piece of hardware gets its own numbered inventory marker. In accident investigation and restoration work, the chain of custody is everything. Lose that, and you lose the narrative. We don't lose narratives here at Aqua Revive. Before any real inspection can happen, the surfaces have to be readable. We start with compressed air. A 120 psi blast that lifts months of mountain grit off the casting ribs and sends a cloud of particulate swirling under the overhead lights. The orange tags flutter violently, then solvent wipes, cotton swabs into every recess,
Okay,
and
begin
slowly the true
shutdown
character of the
sequence.
metal reveals itself.
Understood.
That light
Disengaging
aircraft
rotor.
gray paint is
Power is
softer than it looked
isolated, safe
outdoors.
to lock.
Satin
Good.
matte.
Tag
The
and
chips
verify.
and scratches read differently under artificial light. Sharper, more deliberate, like brush strokes. The pitch links come off first, 4 of them, each connecting the inner and out. Swashplate rings to the individual blade grips. They line up on the workbench like a set of parallel arguments. Same geometry, different degrees of wear. The yellow tape markers stay in place. We are not cleaning these yet. We are reading them. The safety wire patterns tell us about the maintenance history. The wear on the ball joint races tells us about the flight envelope. Every scratch is a sentence in a story that started before any of us were in the room. Now we can see what the mountain really did. The Swashplate inner ring shows concentric wear lines that should not be there. Evidence of a lateral load event, a force that pushed sideways through the Swashplate plane. The bearing ball tracks are polished to a mirror finish at their extremes, which tells us the mechanism was driven hard against its mechanical stops more than once. And the damper on Station 3, the one on the starboard forward position, has micro-pitting on the rod that a steel damper should never show. That's fatigue. That's time and load cycles written in metal. The blade root fragment goes under the ultrasonic probe next. Gel applied to the fracture surface, the transducer dragged slowly across the face of the damage. What we're mapping is the internal delamination, where the carbon layers have separated from each other below the visible surface. This is critical. Carbon fiber composite fails internally before it fails externally. The mountain showed us the outside of this failure. The ultrasound is going to show us how deep it goes. The answer, when it comes back on the screen, is sobering. The delamination propagated nearly 14 inches from the visible fracture point. This blade was already dying before it broke. By the end of the first full workshop day, every component is laid out on gray anti-slip matting, orange tags at corners, photographed from above for the permanent record. The assembly looks, from directly overhead, like an exploded engineering diagram, the kind you'd find in a maintenance manual, every piece in its proper relational position, everything readable, nothing hidden. Tomorrow, we reassemble what can be reassembled, and we begin asking the hardest question of this entire project. What exactly happened, and can any of this fly again? Day 2 in the workshop. Coffee, clean gloves, fresh safety wire. The pitch links go back on first, torqued to spec with a calibrated wrench, new cotter pins ready at each castellated nut. There's a rhythm to this work that I find meditative. Wrench, torque value, click, visual check, safety wire, twist pattern, cut, tag, move to the next joint, 4 links, 32 fasteners, 100% documented. This is what separates restoration from repair: intent, process, and the willingness to do it the slow way. The bearing preload adjustment is the most exacting task of the whole project. A feeler gauge thinner than a business card, we're measuring thousandths of an inch, is slid between the bearing race faces while the assembly is loaded and unloaded by hand. Too loose, and the bearing will walk under dynamic load. Too tight, and heat will build until the grease fails. The target window is narrower than the tolerance on a good surgical instrument. We land it in 2 attempts. The tech doesn't celebrate. He just writes the number in the log, caps the grease fitting, and moves on. That's the culture here. While the hub team finishes the swashplate reassembly, a second team has been working the long bench, laying out the blade fragments in sequence, trailing edge to leading edge, root to tip, reconstructing the original geometry of the blade. Pieces that were 40 feet apart on a mountain are now 40 inches apart on a workbench. Orange tags mark each segment. The missing sections, perhaps 18% of total blade area, are outlined in masking tape. It's a sobering picture. The leading edge abrasion strip on the longest fragment is torn and scraped, metallic sparkle where the ton. G-Steen carbide coating was ground against stone. That abrasion strip cost more than most people's first car. With the hub and swashplate fully reassembled, we move the assembly to the test rig. This is a static platform, no rotation, no engine power, but it allows us to actuate the swashplate through its full range of collective and cyclic travel, verify the pitch links are moving the blade grips correctly, and confirm no mechanical binding anywhere in the system. Sensors are taped to the hub in a grid pattern, yellow tabs marking each location. The actuation begins slowly, manually, one of our technicians cycling the swashplate controls by hand. And it moves, smooth, silent, precise. After everything this machine has been through, it still moves like it was built yesterday. Every restoration project at Aqua Revive ends the same way, with the permanent record. The yellow evidence tape comes off, replaced by archival labels in the same orange and white color family, printed on materials rated for 50-year storage. The composite fracture surfaces are stabilized with a clear consolidant resin. The black carbon layers locked in place, visible forever, but no longer able to shed fibers. A color calibration card goes into the final photo frame alongside the complete assembly. The camera shutter fires 47 times. Every angle, every face, every fastener head, documented. The final display layout is something I've been thinking about since the moment I first saw this system lying on that mountain. Hub and mast in the center, swashplate and pitch links flanking left, blade fragments arrayed in their reconstructed geometry to the right, root segments close, tip fragments extending outward, orange and yellow tags consistent in color, consistent in height, the visual language of the recovery carried all the way through to the final presentation. Under neutral softbox lighting on a gray cyclorama, the dull silver of aluminum and titanium has a quiet authority. This machine doesn't need drama to command a room. It just needs light. We went back to the mountain one last time. The debris field had been cleared. Only the footprints of the team and the impression in the scree where the hub had rested for so long remained. By tomorrow, even those would be gone. Wind and frost take everything eventually.
The
But what was
hub
here,
emerges
the ingenuity,
with
the
orange
engineering, the
tags
machine built to
glowing.
carry people through difficult air, that's in the record now. Tagged, measured, tested, stabilized, and preserved. That's what we do at Aqua Revive Restoration. We don't just clean things up. We read what they have to say, and we make sure those words last. If you found value in this documentation, hit that subscribe button. Drop a comment below. What part of this recovery surprised you most? And if you want to go deeper on the technical side, the swashplate mechanics, the carbon fiber failure modes, the bearing preload procedure, let us know and we'll build a full technical breakdown. This was a big one. Thanks for watching all the way through. We'll see you at the next site.